Welcome back to Daytime Ottawa. We love learning.
We do.
And you know what? We're going to learn about airflow and air pressure right now with Dena Splinter. She is one of the presenters for Scientists in School, and she's here with us today. Welcome to the show.
Thank you. Nice to be here.
Well, we love learning, like I said, and you're going to teach us about the Bernoulli effect, I guess. So how are you going to demonstrate that for us?
Okay, we take science workshops into schools all the time to try and make science fun and engaging for kids.
Right.
So we brought a few of the, I've actually pulled pieces from 2 different workshops that I do. One of them is force and its effect on structures, which includes air pressure.
Okay.
And it's really easy to take air for granted. People look around and say, well, there's nothing in this, we're surrounded by it. But air does have a mass, air can exert a force.
Right.
And this is called an air drum. So if you have some kid that's kind of not paying 100% attention somewhere, and you want to make sure you get them engaged in what you're doing, is we talk about the pressure that air can enforce, and we go up to them with an air drum, and we go, oh my God.
That'll hit you.
Usually by the time we move the bangs off their face, we've got their attention, and they have a new respect for air.
So that creates a puff of air.
Quite a violent puff of air that can come out of here, and it's a very simple thing to make. You can make one at home. It's a wash basin with a hole cut out of it, tightly sealed. But if you apply pressure on this side, you certainly get a force coming out of this side.
Yeah, parents are loving that. They're going, okay, brothers and sisters out there.
March break, we've got an activity for the kids.
What's next? What else have you got?
What do we got here? Well, you mentioned Bernoulli. We're not going to get away with Bernoulli, but so we do a little demo with the kids, and I'll let you do the demo.
Okay.
We ask them, we give 2 pieces of paper to each student.
All right.
Ask them to grab it by the top in the middle and face the 2 pieces toward each other. I guess I should have grabbed another set for myself. And about 10 centimeters apart. But because we're scientists and we really push the scientific method, before we let them do anything, we make them at least inquire as to what might happen. So what we're going to ask them to do is they hold these 2 pieces of paper, and they're to represent buildings, what would happen if we got a fast-moving stream of air going between these 2 papers. We ask the kids to blow. Don't do it yet.
Okay.
But before they blow between the 2, we say, what do you think is going to happen? Are the papers going to move apart? Are they going to be pulled together? Are they just going to stay where they are?
Interesting.
So we let them think about that for a few seconds. They have to jot something down on a page. So then you hold it up in front of your face.
Right.
And be about 10 centimeters, 4 inches apart.
Should we guess first?
You can guess first. What do you think is going to happen?
I think they're going to come together.
Okay. And
Lois?
I say they're coming together. Come together.
Come together right now.
Oh, a nice Beatles tune.
So you blow between the 2 pieces of paper and observe what happens. Wait.
So they are coming together. Now, Dena, the question is, why are they coming together?
Why are they coming together?
And I'll be honest, the only reason I answered they were coming together because I thought it was too obvious that they were going to go apart.
And I agree with you. Most people would expect that you blow toward, if I blow toward 1 piece of paper, it's going to go away from me. 2 pieces, why wouldn't they go away from each other? Then we get back into Dear Mr. Bernoulli. And the, science is based on observation. And Mr. Bernoulli in the 1700s noticed that fast-moving fluids, whether they're liquids or gases, create a bit of a low pressure system. So what you're doing by getting a fast-moving stream of air is you're creating a low pressure between the 2 pieces of paper. And yes, a bit of a vacuum. They pull themselves together.
Interesting.
So the surrounding air is a higher pressure pushing them together.
Nature abhors a vacuum. So if you create a bit of one, it'll try and fill it in.
All right.
So we use that principle to explain the windbag.
Ah, the old windbag.
The old windbag. And I often tell the kids they might think I'm a windbag if I talk too fast, but have I got a windbag for you?
I promise you.
So we'd be welcome to let you try it if we have some time. And the idea is, how many breaths of air would it take to fill the windbag? This is just a long balloon.
It's huge.
That's pretty big.
It's pretty big.
A dozen.
A dozen.
I would say 6.
6. Would either of you like to try and fill the windbag?
Okay.
Okay, go for it.
Try it, Lois. Okay. 1, 2, 3. We need a counter.
Do I have to close it after, or do I have to keep puffing?
Well, up to you.
Look at Dena just, she stands back.
Is there a hole in
up to
this
you.
bag?
No, air's going through. I see.
I can see a little air in there.
Yeah, it's not bad. Where are you up to now?
About 8.
8,
Eventually
9,
she'll get lightheaded.
10. Yeah, she could pass out. I think.
Glad, please don't.
Safety first.
I think you're right.
I think you're almost at a
12?
dozen here. That's 12?
About 12.
All right.
Okay, so, we're going to take the air out of this bag.
After all that hard work,
After all
Dena?
that hard work.
Give her a
because
break.
there is an easier way. We'll ask you to hold this in.
Okay.
And again, we've got to remember what we've just been talking about. We've been talking about Bernoulli, low pressure, fast-moving stream of air. So if it's a good day, and I always warn the kids if it's a good day, because sometimes this works better than others.
Okay.
I'm going to attempt to fill this bag with less than 1 breath.
Okay.
All right.
Okay?
Okay.
So.
I don't know.
Look at the preparation over there.
I feel like this is a magic trick.
Oh my God.
And I tell the kids there's no such thing as magic, folks. It's only science. So what have we done with the windbag? You notice I didn't blow really hard for it.
Right.
I just tried to get a fast-moving stream of air going
Right.
toward it, just toward it.
And you didn't close it over
No,
your
I
mouth
certainly
either,
didn't,
right?
because by getting us low pressure created inside the bag, I really tricked the air in the room for jumping in the bag for me.
Very cool.
And I just capture it.
We're down to less than a minute. You have one more thing, because you brought a blow dryer along. I'm guessing you're not here to style Lois's hair.
No, I think I've already done that.
She'd love it. What are you going to do with this?
Well, and again, a little bit of air pressure and what we can do with it. Fast-moving stream of air, low pressure. So it's just a hairdryer and a ping pong ball.
Okay.
I'm going to turn the hairdryer on high, put
Okay.
it on cold. We don't need the heat. And no real surprise that I can usually suspend.
Magic.
I love that.
That's
though.
not
Every
magic.
kid loves
But
seeing
this
this.
isn't the fun part.
Okay.
Blowing from the bottom is kind of the expected result. But what I love is when I can turn it on its side and it stays there.
And it spins.
Oh my goodness.
That is
So
That's
gravity
awesome.
will eventually kick in here, as it does. But in the meantime, we've suspended it in a low pressure system.
And Dena, these are the types of experiments that you showcase to children when you go to school, so people can basically contact scientists in school and have you come in and show the
Yeah,
show
we
the
do
kids all these
workshops in
different
schools. We try to make science fun and entertaining and engaging for the kids. We want a whole bunch of scientists being produced in the
Well,
schools.
we were entertained and engaged.
That
so
was a lot of fun. Thank you so
Good
much,
stuff.
Dena.
we
Glad you
enjoyed
enjoyed
it.
it.
Thank you so much, Dena.
All right, it's a charitable organization, and if you're a school member or a member of a school out there, maybe you're a teacher, give them a call. Scientists in School.